Go time. All right, second hour's being taped. Oh, I didn't take attendance. Already get a stop. Okay. All right, so today should be easy, but it is going to take a little bit of time doing Webster's method. And I just realized I screwed up again, that I need to erase last hour's notes. So I will move this up a little bit so you can write these down, and then I'll, read for you, so to speak. We're back. All right, we're back. I've done all my things I need to do. Get ready for second hour. Okay. There is only one minor difference, ma'am. Shh, that's fine. I'm in the middle of a tape. I agree. This is terrible. Then this joker has. Oh, I thought that was your phone. You're lucky. All right. Okay. All right. So there's only one difference today. There should be no problem with today's notes. None whatsoever. All right. The Webster method. What's the only difference compared to like all the others? What's the first thing that's weird? What do they actually do? Now that you've written this down? You round what? Mathematically is the way I like to say that. And then, so some examples of this that you already wrote down. What does 1.5 round to? 2. What is 23.41 round to? 23. And then what does 0.47 round to? Actually, so for instance, what's 8.47? What does that become? Because sadly, what I see people do is they take the 7 and round that 4 to a 5, and then take that 5 and round the 8 to a 9, and that's incorrect. 0.47 is 47 hundredths. 47 is closer to 0 than it is to 100. So that's why 0.47 rounds down. I'm teaching seniors how to round. All right, here we go. All right, so because I've seen some major rounding errors throughout the year, the last chapter we had some rounding things we had to do, and students were rounding wrong. All right, so first thing that's different, okay, now let's go back to this. The Webster method is the same as a Jefferson method as it is a divisor method. So we're going to divide by a divisor. If we don't get the right amount of seats given out, then we have to modify the divisor and divide again. It is nothing like Hamilton and Lowndes. So that's why I mean that this is very similar to Jefferson. The only difference is how we round. That's it. So it's almost the exact same notes as yesterday except the rounding aspect. So if the sum does not equal M, and M is what we used for a letter that said the amount of seats to give out for House of Representatives. We had the bottles thing yesterday. How many bottles were given out was M, whatever. Then you have to find a modified divisor. It's mathematical common sense. If I have given out too few seats, if we're talking about the House of Representatives, then the modified divisor needs to be decreased because when you divide by a smaller number, the numbers become what? Larger. We got someone right on task with me right here. And if too many seats are given out in any step, you increase the divisor because when you divide by a larger number, the numbers go smaller. Mathematical common sense. So, steps are, you get your original divisor, divide. Fail. Depending on whatever scenario you have, modify the divisor. Hopefully you get it works. If it doesn't, then you do it again, and again, and again. And hopefully it doesn't take that many times. Hopefully your mathematical common sense comes into play to get educated. We'll do the same old. One example that's not a House of Representatives. Then do the same example we did from day one in this chapter using a different method. And I keep forgetting to compare the differences, who gets what seats when we did that fantasy little country, the different ways, but probably forget again. All right, so there are 7 sections to a portion. Now just get in the spirit of the question that we're going to portion. That means we're going to divide up these in some sort of way, but we can't have a fractional section, so we'll do it in the spirit of Webster. So we're going to use Webster to do so just to practice the idea. Okay, so we have 4 different classes with the amount of students listed in that chart. The first step is to come up with your original D, not a modified D, this just the one that we're going to use initially. And that comes from, just like the bottles yesterday, the population was actually the money that the people put in. That was kind of weird. I get it. This is pretty easy. The population is right here. And for purposes of not having to have you add, I do have this listed somewhere. What is it? Nice. Thank you. This student's on fire over here. 206, add it up. And then what we need to do is 206 divided by 7, which was, what was that again? 0.43, wasn't it? Okay, let's do that. So what that means is we're going to go to our graphing calculator, if you don't mind. Okay, that looks pretty good. I think I'll be able to open up the calculator and hopefully be able to move it without it going. It went crazy. Oh, that scared a student. Are you okay? Saw somebody jump. Ah! Yeah, oh. I did it. All right. Okay, now, and you take the time. Clear, enter. And then I guess I don't really need to clear enter because I'm going to overwrite that L2 in a minute here. But we're just going to do these just for the spirit of the calculator. So again, what? Okay, quit. This is fun. I'm glad this is on. All right, good. Those that are behind and haven't gotten out their calculator yet, I guess I didn't say that real quick. You hit stat. Look at how that lights up in red. Love it. Stat, and then you just hit enter on edit, 1. And then you're in this L1. And then you go up here and clear the list if you do have numbers there. Then you proceed on. And then type in these numbers. Okay, now we're good. 69, 64, 32, 41, hike. And then you go over here, and then you go up to L2, and then you hit second. You see it lit up in red there? 1, because that is L1's name. And it goes right here, L2 equals L1. This is if someone has not done this. Hold on, we got a customer. L1 divided by that 29.43. Now, you're certainly faster than me, all these interruptions and stuff. Okay, and then this is what I want you to write, 2.3. You don't need, just do 2.3, even if this rounds or not. And what does that become? 2.3 becomes what? 2. Well, it's kind of the same, but you do round down with 0.3, so it's not really the same. And don't write 2.2, do 2.1, because it's the one that rounds up or down, and of course that rounds down. 1.0, that rounds to 1. I know it's 1.08, which becomes 1.1, but you're going to make a mistake if it's 1.47. You're going to write 1.5, and then you might round it up to 2, and that's incorrect. I'm live right now, Chief. If you don't know how to do the calculator, you just got the one today, so we're going to have to watch. All right, back to the... No, George. Well, I said your name online. It's illegal. All right. 6. Is this good or bad? This is bad. Okay, shh. What do we have to do with the modified divisor now? I'm going to put this as MD1, modified divisor 1, and then this will be modified quota 1. So this is our next test. So what do we have to do with the modified divisor? We have to increase it or decrease it? We need to decrease it so this number or these numbers potentially go up. So, any guesses? 20? Ooh, that'd be huge. Okay, 28? Let's try 28. Let's try 28. Now, with the graphing calculator, all I have to do is go up to L2 and hit second L1 divided by 28. I think last hour we did do 29, and we really did not see a significant difference at all. Now, here's what I'm saying. This says 2.46. I know that rounds to 2.5, but you better just write 2.4 because that's the first digit that tells me this rounds up or down, and what does it do? Goes down. But isn't it close? 2.28, just do 2.2. I know that's mathematical, but really it's only the 2 that matters. 1.1. Now this is going to work a lot smoother than the last hour. Like I said, last hour we did 29, then we did 28, then we did 27. because, we hit 28, and then did 28 make it, yes or no? No, it didn't. 1.4 is still 1. This is 2, 4, 5, 6. So now, let's go through the pain of last hour, because this is going to happen to you. Let's do 27. MD2, modified divisor 2, will do 27. Because it's still too small, we need to increase this number. Did you just hit her? And then we want this quota to go up. So I'm going to go up here. Second, L1 divided by 27. Entry. Ah, no. 2.5 is what, everybody? 3. Sorry for my arrows looking bad. 2.3 is what? 2. 1.1 is? But then here's the bad thing. 1.5 is what? So what do you think we did last hour? Modified divisor 3 ended up being what? 27. Anyone? 0.5. We need an answer in between these two. Because this flipped over to 8, which is too many. So I needed something in between there. Do write your modified divisors. Do tell me what you did as you went through the process. You can type fast on that. I have to teach, discuss. You should be able to go twice as fast as this and just write them down. Divided by 27.5. And then bingo. 2.5 is 3. But then if we look at this one, this is 1.49, which jumps back to 1. And the other ones stay right where they were. So now we hit it. 2.3, which is 2. Now, 3, 4, 5, 6, 7. Kind of rough, but this is the apportionment. I don't know why I have the 6 circled. This is a winner. So these are how the classes will be assigned. Oh, 1 teacher for 41 students. Rough. 41 teenagers. Yeesh. That's you guys. Does that make you upset? Okay, then here we go. Oh, wait, should I stop? Yes. All right. Sheesh. Like I said, it's taping. We're going to do the same fantasy country with 5 states, 18 million people, 300 seats to give out, but we're going to do it through Webster's method just to go through the differences. And I don't have all the other ones to show, who ends up different with different assignments. So, I don't know. You could just say that. Same example, 18 million people, 300 seats, and then I could zoom in on this. 18 million divided by 300 is that 60,000. That gives us the first quota. So the first D is 60,000 from that 80 or 18 million divided by 300. And then this is our first quota. But now, actually, it starts off completely different than all the others. What's 72.08 become? 72. What's 43.916 become? Now here's the difference. In our first divisor and then quota, we have to actually round mathematically. What's 82.78? 83, 50.7, 50.5. And then guess what? When you add these up, this is, for the first time in forever, 301. Which is what? This is too big. All the other ones, you lopped off the decimal and got 297. And then Hamilton and Lowndes are a completely different thing. Jefferson, we had to modify the divisor to try to hit 300 on the dot from 297. This one we're at 301, but aren't we close? All right, so what do you think our modified divisor should be? Last hour hit it right on the dot, or there is a range that works. I will be honest with you. And that's why I want you to write your modified divisors. Everyone, might have a different answer because there's a whole bunch that'll work. So what do you think? By the way, does it have to go up or down? Up. This has to go up because 301 needs to what? Go down. It needs to get smaller. So our modified divisor needs to be up. Did it need to be moved up a lot? No, look at this last one. I think I have an idea who's going to end up not getting it, but I need it proved mathematically. What state probably is going to end up being 50 instead of 51? E. Do you think I need much to get that to be 50.4? So what do you think the modified divisor should be? Oh, 69,000. Ooh, that'd be a lot. 60,000. Okay, we're doing 500. That's the first thing I heard. Gun it. Gun it. We'll see if it works. Oh, no. I got to go into the calculator, and I got to type these in again. 4, 3, 2, 5, 0, 0, 0. Enter. 2. This is thrilling. YouTube. 0, 0, 0. 4, 9, 6, 7, 0, 0, 0. Oh, my voice is cracking. 3, 0, 4, 2, 5, 0, 0. You okay over there? Big size. Now I don't have to erase this. I just go up to L2 and actually divide it by that 60,500 that we said. L1 divided by 60,500. And look at what happened. Okay, and I'm going to move this over here. What's 71.48? What's 71.4? Lost one. What's 43.5? Stays the same. So we did lose one. What's 82.0? 82. So we lost 2. We're already done. 50.2. What's that? 50. And then what's 50.0? 50. So we lost 1, 2, 3. We lost 4. Guess where we're at? 297. So now let's think about that. What should we have actually picked? 60,000. 60,000. I want this to work. 60,100. Okay, we want to get away from 500. This caused us 3 seats, actually 4 seats swung to the other side. We actually wanted to be really close to 60,000. So to go 60,250, you're probably going to be in between. You're probably going to be in between 297 and 301, which is like 299, 298. It's probably still not going to work out. So you need to be closer to this one, because this one was really close to happening. We swung way too far to the other side with 500, so we shouldn't be near 500. All right? And then I'll answer your question after we get this one done. Okay, so second L1 divided by 60, 100. Press enter, and then you get 71.9, which is what? Got to minimize. Okay, so hopefully 43.8, which is what? 82.6, which is what? So we got that one back. 50.6. And then we got this one back to 50.4, which is 50. So this is one less than the last one. The first one, I'm sorry. So 300. So this is the apportionment for the states. Okay, I am done.